Next up on the agenda, I'd like to welcome Iain Hayes to the stage. Iain works with integrated monitoring, and he's going to be giving a presentation on scaling wireless EM via Starlink, Edge AI, and virtual observers for real-time monitoring at sea. So please welcome Iain.
Thank you to the audience and the organizer of the event. Great to see the preceding discussions. I think it's contributing to the overall picture that we're looking at, which is really taking a lot of these innovations and putting them into production into large regulatory systems. So let's see if this works. So core to our basic platform is just about everything is going up on wireless. So we now use a combination of 4G and Starlink. We have around 50 vessels already deployed on Starlink globally. We have Edge AI and neural processors at the front end on board the vessel, and then different camera combinations based on what we need to do for the VMP or the vessel monitoring plan, and specific to the audit models that we're looking at in the different fisheries. Then the next question is, what do we do with that data? So with over 300 vessels on the water at the moment, we're moving something like 50 terabytes of data into the cloud per month, right? And this is going to increase as the New Zealand program comes on with 300 vessels. That's around 50 to 70 terabytes of data a month that we're looking at in that program. So we have to meet government security. We have to meet everything to do with the regulations around evidentiary use of data, security from penetration testing, from camera feed right through to review station. So that's something we've worked on with our clients to meet all those expectations. We are full stack in terms of the AI models, the integration capabilities, the cloud architecture, and the review template systems that we provide. We don't do review services. We supply these tools to our partners. They're all internet access based, so you can access them from anywhere on the world on your mobile phone or through Starlink if you're in some remote location. And now we have a few people doing virtual observer on board vessels and writing the reports before the fish leave that particular vessel. This is an example of integrating just the core EM capture, the review templates in the left corner, which we developed based on the fishery method, and then we correlate that in time in terms of what the fishing activity is related to the vessel. And this is an example of a vessel that is pulling all its data up over Starlink 24/7. And just other examples of how that's applied. So detection models, we run the whole gambit of detection models, including crew tracking, which becomes a big issue in terms of what's happening on board. These are some of the early ones we did related to AI activity detection, but specifically with crew or fish on boat or gear movements. We don't use any other sensors than video. And we also do calibrated detection, and you're right, we get about 20 millimeters per the pixel, so we do 1-inch resolution horizontal. This is some of the detection work looking at crew activity, not only for safety, but also in things like pole and line, that becomes the effort counter. Effort per unit is based on how many poles we have. Simple authorization through secure internet access anywhere. Example of some of the projects we're working on recently. We've just started in Africa. Josh, who was meant to be here, is deploying the pelagic fleet in Denmark at this point. Just selecting, you can scrub through on time, on date, and any trip going back. Typically, most review is done within 5 days of trip. Most data is put off into deep storage within 1 month of trip that is accessible. And we can do a lot of just normal selection process in terms of what the fleets are doing. This is an example of a program in the Maldives where we have around 730 polar line vessels out on the water. Some of those are doing EM along with the collector vessels. Simple tools for the user interface in terms of the review software. And again, being able to use things like PTZs to do catch aggregation composition quite easily on deck from the vessel. So virtual observer is probably where this is headed, and distributed observing, so that the observers that are deployed are focusing on their scientific analysis. Need to move on. And again, you hear folks talking about taking this into production. This is what we're doing already in production as far as discard and trawl fishery, ground fishery. So we're doing the same basic technologies that our previous colleague mentioned. We're doing that in real time through discard chutes. So we're doing size, weight, and species identification as part of that process in production. That program is funded under UMass and MIT Sea Grant, and it's being rolled out commercially as well, especially in the trawl fisheries at this moment. And we're also looking at that for audit sampling and even some of the tuna and the purseine fisheries. Now, as part of this presentation, we wanted to present what we're doing on a global scale. And so the New Zealand MPI program, and I'll ask maybe Josh Hobbs to come up. This is the largest EM program globally with 300 vessels, real-time EM. By December of this year, we will have 100 vessels on water, and I'd like Josh to talk about that.
Great, thanks Ian, and thanks for having me here, and thanks to the organisers. It's fantastic to be here and be able to talk about this. As Ian mentioned, we're the Spark Group. We're New Zealand's largest technology provider and help to optimise businesses. We have, as Ian said, 23 vessels live at the moment, with another 65 additional vessels going live before the end of this year, and up to 300 live by 2025. This will give us about 85% coverage of our inshore fisheries within New Zealand. The solution is obviously integrated with IM and MPI. We have activity recognition for identifying fishing activity, so we reduce the amount of data that we're storing on the vessel and also the amount that we need to transmit. We use 4G primarily for upload and data transfer for metadata, and then we have integration of electronic catch reporting and effort reporting as well. This system's all securely hosted in AWS and is integrated fully with MPI eLog and also with all of their geospatial data to ensure that they're capturing all of the information that they need to. It enables MPI to review on a risk-based event-by-event process and allows for alerting when the events don't match the video footage that we currently have, or vice versa. It's a primarily wireless solution that's delivered via 4G. We do have hard drive backup if we need to, and we're also investigating the utilisation of Starlink on some of the larger vessels. It's a really highly integrated and holistic approach to verification, and we've been really proud to be able to start delivering this within our country. Thank you.